Hey guys, welcome back to my YouTube channel. I know I haven't made a video in a while, but today's video will be about IR, which is infrared spectroscopy. And so with the graphs that are given, we can identify functional groups and match them to certain compounds. So at the top, I have some molecules, some compounds. Using the IR graphs down below, we'll identify the functional groups and match them accordingly. So starting off with this first IR graph here, we can see that there's a very obvious hydroxyl stretch, and I'll label it right here. So these hydroxyl stretches usually occur around 3,300. They usually are broad. So as you can see, this is pretty broad. So a broad, big stretch, it's usually a good indicator that you have an alcohol group. Around the 2,900 range, where my arrow is, this is the sp3ch bond. You'll see this with every IR graph most of the time. It'll appear different sometimes, but this will always be there. And in addition to those two, I also see around 2,200 a terminal alkyne. So that's a good indicator of that. And usually with the terminal alkyne, you'll also see a spike past the 3,000 mark, but because the alcohol stretches there, it's kind of concealed. Aside from this, there's no other functional groups past like the 1,600 range or 1,500 range where I'm drawing this line. This is the fingerprint region. With most classes, you don't really memorize the stretches in the fingerprint region, so you won't really be paying attention to that. But anything past 1,500 on the left, we will pay attention to. So this first one, we have an alkyne and an alcohol. If you look at the molecules up above, A does not have an alcohol, B has an alcohol, C does not, E does not have an alcohol, F does not. So our only options are between B and D. And remember, we had the alkyne stretch around 2,200. So B would be the only answer for this first IR graph. So the first one is going to be B. So the second graph, once again, I have around the 2,900 sp3ch stretch. Honestly, like, you don't even have to label those because they're pretty much useless. I don't know why they even pop up anymore. I just ignore them. Anyways, aside from that sp3ch stretch, there are some other pretty obvious stretches. To the left of 1,500. So this first tick right here on the left of 1,500 is 1,600, and the one after that is 1,700. Whenever you see a line like this at around 1,700, it's going to be a carbonyl stretch. Usually it can be lower than 1,700 or higher than 1,700. It just depends if there's conjugation or let's say you have like an ester. It would be higher than 1,700. So yeah, that's a very obvious carbonyl. In addition to the carbonyl, at the 1,600 tick, there's another signal, and whenever you have a signal at the 1,600 range, that's a good indicator that you have an alkene. So an alkene is a C double bonded to another C. And aside from that, anything else is in the fingerprint region. We don't pay attention to that. But yeah, so we have an alkene for the second one, in addition to a carbonyl. So when we look at our compounds up above, we're looking for a C double bonded to an O with an alkene. So A does not have a carbonyl, C does, but it does not have an alkene. D does not have a carbonyl, E has a carbonyl, and it has an alkene, and F does not have a carbonyl. So our only option is E. So here's your carbonyl, and there is your alkene. So for a second graph, E is the correct matching compound. So third and final graph down below, I have the sp3 C to H stretch. Once again, just labeling it for the sake of understanding. But you probably shouldn't label it on tests because you're just wasting time at that point. But aside from that, pretty useless stretch. If we look at the left of 1,500, The only other thing I see is a carbonyl stretch once again, because this is 1600, the first tick right here. That's 1600. And then this one right here is 1700. So this one's actually around 1700. Usually most textbooks will say the carbonyl stretch, if it's normal with no conjugation or whatever, it's going to be around 1710. Doesn't really matter. Just remember it's around 1700. So around 1700, there's a carbonyl, C double bonded to an O. Aside from that, on this third graph, there's no other functional groups. So in my head, when I scroll up, I'm going to look for a carbonyl with no other functional groups, such as, so I'm looking for an alkane with a carbonyl. So a bunch of single bonds aside from the carbonyl. So A, there's no carbonyl. C, there's a carbonyl. D, there's an alcohol with no carbonyl. F, there's no carbonyl. So C is the only correct one because there is a carbonyl right here. And that's the only functional group that is seen there. There's no alkenes or whatnot. The rest of them are those sp3 CH signals. So yeah, so the corresponding compound for the third graph is the letter C, which is this molecule right here. And yeah, thanks for watching. That was a little bit of infrared spectroscopy practice. And I will see you guys next video.